Good afternoon, everybody. Let me introduce our next speaker. Get my glasses. So he is Bob Käll. He's a serial entrepreneur who has focused and sold 3 SaaS startups in transactions totally close 100 million, not bad. His latest startup, Cien, is an AI-first productivity app for measuring the human and behavioral elements that impact sales productivity. Good. The company is based in Miami, Florida, with a commercial office in Dallas, Texas, and the research and development center in Barcelona, Spain. Rob Käll holds a BS in computer science from the University of Borås, not sure if I pronounced it correctly, Sweden, and Florida International University. He and his family shared the time between Barcelona, Spain, and Miami Beach, Florida. So, all yours, Rob.
All right. Can you guys hear me? My name is Rob Käll. Very honored to be here today at the A2IC conference. So I really only have 2 main objectives for this speech. One is to entertain you, and the second one is to tell you about something that I think is thought-provoking. Because I'm going to talk about the most important new idea in the world. So here's some news. I really did not want to be a data scientist. I wanted to be a rock star. This is the real Rob. But for the last 20 years, I've been working, doing AI, data type startups. And as Henrik just mentioned, some of them have had a lot of success and we sold them for some money and so forth. But for the last 2 years, I've been working on this AI-first startup called Cien right here in Barcelona. So before I start, I want to go into a flashback. I think it was December 12, 2010. I was at a business conference in Florida. And I talked about some new trends that were sweeping the world at that point. It was connectivity, mobility, and transparency, and the underlying technology that made those things possible. And I asked the crowd at that point, how many of you guys have heard of the cloud? And there was one person that said, yeah, I know what the cloud is. And today, of course, 8 years later, everybody's using the cloud all the time. So I'm going to ask a similar question today, and we'll see what you guys are answering on that one. So I'm going to talk about something really, really, really important. So it's a question. What's the biggest mystery in the world? And what happens when that mystery is resolved? To understand this stuff, there are 3 systems that you can use to break down things. You can break them down. Almost every problem can be broken down into one of these 3 boxes. So the first system is 13.7 billion years old. It's a physical system. It's the universe. It's, the thing that started with Big Bang. The cool thing about this system is that we actually can understand it today. We can predict it. I know there are people that are working on the unified field theory and so forth, but for all intents and purposes, we can predict what's going to happen. If I drop this thing, we know when it's going to hit the ground. If I smash 2 atoms together, we know exactly how much energy comes out of that, that fusion. Everything we know about electronics, all the modern technology is based on our understanding of this system. The second system is 3.5 billion years old. It's life on Earth, biology. We're understanding to a very large degree that system too. We have genes, we have DNA. We even have a tool called CRISPR today that allows you to do cut and paste of various genes so you can create this new life form, basically. And I know we're not, solving every single problem in terms of, cancer and designer babies and so forth yet, but to a very large degree, we can understand and control biology already. The third system, it's only 50,000 years old, or maybe 70,000, but that time, something called the cognitive revolution started. And that was what made humans. Homo sapiens existed before that, but humans started to become humans. This complex, cultural, social, connected system that we are living in today started to come up. The thing about this system is, it's still a mystery for us. We don't know. Like, I don't know what's going to happen in this presentation. I have no way to figure out if you guys are going to laugh at my jokes, and I have a little algorithm that I can put in and say, this is going to be funny or whatever, or you're going to be bored with the next slide. But all of this stuff is about to change. Because we're going to look at some quick examples here. Human behavior, that is what is the big mystery. First one. What's up with this guy, you know? Why did he do that? What does his girlfriend think? And what would happen if they asked the girl on the left out for a date? You know, we don't know any of those things. We pretty, you know, we just have gut feelings. I mean, I think the girlfriend would be pretty angry, right? But, you know, look at this guy. We had no way of predicting in 2014 that this guy was going to be president. And we have a very hard time understanding if he's going to be re-elected in 2020. He's the most powerful man in the world. Why couldn't we figure out that? We were getting some things. There's things like collective intelligence, where you're using human intelligence in things like polling or prediction markets and so forth. But there's no machine yet that determines whether he's going to be re-elected or not. This example is even harder. Look at this beautiful boy. Oops. What's going to happen to him? Will he grow up to be a criminal, even a murderer? We have no way of knowing. What's the probability of that stuff? And how would that probability change the day he becomes friends with that weird kid down the street? I mean, I know his mom doesn't like it. But, you know, there's no way to understand that. This is a challenging problem because the time horizons are very, very long. It could take 20 years from him to go from this beautiful boy to that terrible person, right? So we have the social sciences, you know, sociology, economics, psychology, that is trying to understand that. But the truth of the matter right now is that those tools are not that useful. They can't be used in daily life. I'm a big fan of a guy named Daniel Kahneman. He won a Nobel Prize in economics that allows you to understand, because he pinpointed how humans are biased for certain things and don't always act rational. And I know about his studies, but I can't apply them in real time. But all of this stuff is about to change. We're moving from the research phase of human behavior into the engineering phase of human behavior. So I'm going to present to you right now what that is. It's called the Demystify box. You like that name? I came up with it like a couple of weeks ago. It basically, I'm sure you understand what it does, right? It demystifies human behavior. By the way, anybody here that watched the Silicon Valley show? Yeah, a few? Okay. My prediction algorithm said that like 3 or 4% would get that joke, but it's Gavin Belson. You should check it out on YouTube. It's really funny. Anyway, the Demystify box is a brand new thing that allows you to understand human behavior. Kind of sounds like science fiction, right? But it's only dependent on 4 key ingredients that almost all of you guys here already work with and understand. So I'm going to go over those right now. First one is sensors. When you think of sensors, you probably think of things like IoT, Internet of Things, and so forth. But the biggest sensor is this thing in your pocket. It records, you know, a very big portion of your day. Like, there's a program now called Screen Time that is just scary to look at because you see how much time you spend every single day on your phone, right? It records where you are, what you're doing, and even what you think about things. Because when you write a message to someone in WhatsApp or whatever, you're sharing your thoughts. So that's a sensor. Very, very big data. I told you, I'm old. Been working on data for 20 years. We used to have to purge data all the time. That's no longer needed. Google has saved every single search that you have ever made, right? You heard that. Also scary. But when you have this very big data, you can start storing not just how things are today, but how they were before, and before that, and before that. You create what we call time series, right? Or in psychology, you call it longitudinal studies. So it allows you to understand if this starts here and then becomes this and then becomes that, you have that outcome. This didn't exist before, but now it exists. Next ingredient, of course, machine learning. Many of you guys work with that on a day-to-day basis, right? It allows you to build models, and you can build models that are, you know, it's not easy to use this data. Almost always the data is crap when you start, right? So you need to figure out how to do that. And then what we have started working on, and our companies started working on, is to have to generalize certain scenarios. It is possible to classify what used to be fuzzy concepts, such as if someone is kind, if someone is lazy, if someone is engaging, right? I'm trying to be engaging right now. Once you have those things, you can start making predictions. And the last thing that is really, really important is that human behavior, by definition, is always very, very dynamic. It relies on feedback loops, amplification effects. So you need to have those taken into account, and you need to, you know, your algorithm that you got to work will not stay perfect. It needs to be retrained with the new data. So if you're trying to solve a problem that has a short feedback cycle, that's much easier than the one that I gave example on before with the boy that turned into a criminal 20 years later. So here's the crazy part. We actually built the Demystify box. Even crazier, it works. But of course, it doesn't work for all things at all times. It works for a very specific problem domain. So that problem domain, we went after a problem domain that has a very high economic value. I don't know if you guys know this as data scientists, but your work is valued very, very highly around corporate offices and stuff like that today, right? So, as a matter of fact, there's a company or a research organization that's called IDC. They put $1 trillion price tag on the problem that we're solving. And the problem we're solving is that we help sales teams sell more. Sounds easy, right? Think about it as a Google Maps. I'm sure you all have used that to the left. This is our version of that, turn by turn. What are you supposed to do next in order to sell better? So how do we pull this off? Well, we benefit from the fast feedback loops that I was talking about before. We get new sales data coming in from our customers' databases every single day, and that is a big benefit. And then we have behavioral data that we can extract from that data and from other things. So let's go into some specifics and look at what we're doing. I went through the 4 things that were needed before. Here are our 4 things. Sensors. Most of it comes from a system called CRM. It's a database of sales activities. You know, you put in if you're selling something, you put in a meeting, you put in, you know, how interested a particular customer is. That data is far from perfect, but we're connecting securely to each one of our customers and sucking in that data. But all of the data that's needed is not in that database. We're also using app-based surveys, so we can ask any question from any of our users to kind of try better understand what really is going on. Taking that together then, we put it all into our big data. We're using MongoDB, so common document database. And we set it up in such a way so we can do very large, massive processing of complex data sets. If you're doing data science, you're probably familiar with this. Scikit-learn, Python, NLTK. These are common tools, nothing special about them, but we are using them in a special way. For example, we are challenged that a lot of our data is very low quality. And we've created hundreds of individual models that each add some additional value to the data set. So many of those models just deal with fixing the data that we have, and then we do what I call semantic classifications. And again, giving examples such as figuring out if a salesperson's work ethic or a customer's interest level. So when we have those things, we can start making predictions. And despite being an early stage startup, we're already doing over 100 million AI predictions every single day. Lastly, as I said before, we are fortunate to work in an environment where we are constantly getting new data every single day. And we can also quantify the success of our product because if you're selling and we can predict what you're selling, then we have succeeded, right? And if we can make an improvement in the productivity, then we have created economic value. So we retrain our data sets daily, and we have concepts such as local and global models. A local model is something that is specific to that customer's data, because behavior cannot be different from different companies. And global models are applied to the entire system. The cool thing about this is that our systems get a little bit better every single day. So what do we learn when we have done this stuff? Well, first off, doing an AI-first startup that tries to predict human behavior is very, very difficult. I did not think it was going to be as difficult as it was, but we need to be data scientists, we need to be software engineers, we need to be UX designers, we need to be sales experts, we need to be economists, we need to be psychologists. It feels like we need to be magicians to make this stuff work sometimes, right? But when we have figured out how to run millions and millions of AI predictions every single day, all of a sudden, information that was before hidden away, sitting just in the gut of someone's thing, can be quantified and tracked and measured, right? And we're super fortunate to have an extremely talented team, some of them are here today, that made this stuff happen. So now we know a demystify box can be built. So let's look at another example that hopefully resonates with a lot of you guys. The job search. Seems like a mystery, right? On the surface, when you're applying for a job, the odds always seem low. There are 100 applicants, only one guy getting hired, right? Or one woman. But that's not the full story. As a hiring manager, you cannot interview 100 people, right? So the first thing you need to do is to bring it down to 10. And you use all these different techniques to do that. You look at misspellings on the CV, or you're making sure that they have the basic qualifications and so forth. So now you have it down to 10. Let's look at a specific factor. If you're a recent graduate, you might be tempted to put some of your extracurricular activities on your CV, like you were president of the chess club. Well, I got news for you. That doesn't matter at all, right? As a hiring manager, you don't care. So wouldn't it be nice if you had a tool that could show you that you're just wasting your time creating distractions when you're putting that chess thing there? Here's another thing that does matter. Good fit. But what does that mean? It's like a fuzzy, loosey-goosey term, right? It doesn't seem very quantifiable. But we know that the guy on the left there, I don't know if you know him, is from The Simpsons. I think his name is Barney Gumbo. He's not a good fit for pretty much any position. He's a drunkard, idiot. Sheryl Sandberg are going to write, despite recent controversies with Facebook and so forth. She could be argued that it's the best employee ever. She helped Mark Zuckerberg build this amazing business, right? And the thing is that all the things that makes her a fantastic employee, independence, work ethic, cognitive ability, leadership, all of those can be independently measured and quantified. And for the rest of us, that are somewhere between Barney and Sheryl, I mean, we can start understanding where our skills are and quantify that. So this is how the world works. You saw it here first. This is how the world works. The combined probability factors depends on many different things. But you have to clear these first qualification hurdles. If you don't pass those, you're out. With human behavior, hardly ever have linear relationships. So trying to do it through linear regressions and stuff like that typically does not work. And factors are often multiplicative. That means that if one of your things is 0, the whole thing goes to 0. If you're an idiot like Barney, you're not going to get the job. It doesn't work. Wouldn't it be nice to know what you can do to get past, you see that inflection point on the curve? I don't know if I can point it. No. All right, you see where it turns up, right? How do you get past that curve so you're on the right side of that? That would be nice, right? That would be what the demystify box would tell you. And I'm sure that someone is working on that particular problem right now. Okay, something else. One more insight. You know, many of you, if you put, just surfing the web and stuff like that, you see like the 10 most important attributes of a great leader. You know, at CN we're often asked, what makes a great salesperson? I found this drawing that tries to explain all that stuff. You like this? No? It's complete BS. Of course, Jack Ma is not, successful because he's more honest than everybody else. Of course, it's not that this guy, Bill McDermott, has high energy. I mean, it's helpful, but it's not what made him successful. What made him successful was that he cleared all the hurdles. He didn't go to zero in any of the categories. And then he did something that is more important than anything else in the world. Grit. Have you heard that expression? It's a US type of thing. It means that you're doing things over and over and over again despite facing setbacks. Because if you have grits and you handle the things, even low probability odds will eventually come true, right? And that's again something that if people could understand that, see that, all of a sudden their life would change, right? So you will start to see these demystify boxes over and over again in different contexts. It will be more and more predictable, and contributing factors will be clearer and clearer. So the person that has this type of information will be able to optimize his or her own behavior. So if you have the optional disadvantage, would you take advantage of it? My generation, again, I'm going back to how old I am. But, 20 years ago when I started doing business meetings and stuff like that, going to a new city, I didn't have GPS. I had this stupid, rental car map and so forth. And I was lost all the time. Today, I would never dream of pulling up the map because I have my Google Maps in my pocket. Never go back to that. When you have the demystify boxes, you will never go back to not having them. So we're entering a new reality. This drawing is called the Flammarion engraving. And it illustrates how modern man became aware 500 years ago that, it wasn't exactly like they had thought before. There's the sun is just a star, and the planets are circling around the stars and so forth, right? All of that stuff changed human understanding. AI and the technology we talked about today will also do this. It will change again. And I haven't even started talking about all the crazy things that will happen as a consequence of that. There will be privacy implication. There will be possibility to manipulate people in bad ways and so forth. All of those things will be, debated and legislated and thought about a lot. But we need to be understanding that we're about to change a new stage of humanity. And as we become aware of that other people's and our own behavior can be predicted and measured, our behavior will change. And it goes back to this whole importance of the continuous retraining, because it will be feedback loops after feedback loop after feedback loop. So it goes back to the original question. What's the most important new thing in the world? It is what happens when everybody in this crowd has a demystify box at their disposal at all times that guides their behavior. Thank you so much. I hope my primary objective of entertaining you was okay, and that you thought it was a thought-provoking. Any questions?
Thank you very much. So thank you very much, Rob, for the great speech. Any questions for Rob?
No?
Okay, we have one question there.
Go ahead.
Thank you so much for that great talk.
Thank you.
My question was, it was very convenient that you have the demystify box as a black box.
Okay.
And I'm still wondering what goes in and what comes out, if you can elaborate on that. Thank you.
So the answer is, it depends, right? which is the most convenient answer you can ever give in a Q&A session. But in our case, what goes in is the sensors. For us, it's a database of activities. That database has terrible quality, and we have to spend a lot of time fixing that data. And also, you know, human sentiment. You saw we had little surveys, and we asked different things about that. So that goes in. And then what comes out of that? It's essentially a pyramid. I don't have a slide here right now, but for when people are asking about how technology, look at it as a pyramid. Bottom layer is just organizing the data, then cleaning up the data. The next level is what I call semantic classifications. So we're trying to apply, for us it's important to understand whether a salesperson is a good closer, okay? Or if he's lazy, we call that work ethic. Or if the customer is interested or disinterested, right? So those are the classifications. Once we have that, we'll do predictions. And once you have predictions, we are even adding another layer, which is very complicated, and I don't want to go into it today, but it's called economic value, where we are understanding the economic value of these different things. And then the final layer is the turn by turn. You saw, you know, when you're using Google Maps, you get turn by turn. We give the same turn by turn. It's called prescriptive analytics, where we are looking at the most optimal way to take all of this data and present it to you so you can change your behavior in some way to produce a better sales result.
Thank you.
Okay?
Okay, thank you. Any other question? I have a question for you.
Okay. Sure. Go ahead.
Thanks for a great presentation.
Thank you.
So I had a question about how you sell this technology. So when you go to clients and do you have trouble trying to sell the technology, explaining to them how the algorithm works? Because I myself work in a SaaS business that works with customer data sets and runs predictive algorithms, and we have a lot of trouble selling it because they need to see results straight away.
Right.
And, yeah.
So the answer is, selling is always difficult, and that's why we created this product, because it helps people sell, and we're using our own product to help ourselves do better. But in general, if I can show people that small changes in their team's behavior can yield incremental improvements, and we measure that stuff on a continuous basis. We have created case studies, we have created, you know, very specific tools that tells people, hey, you're already making progress. If I go back, I can show you here. I don't know if you can see it. But one of the things that we're doing is to show the quantifiable economic value that our product is delivering in real time. That was that complicated thing I didn't want to go into, because we can talk about that for 2 hours. But that's how we're selling that, right? And then, of course, we are an early stage startup. We only have a couple of salespeople. We're not selling a lot right now. But the idea when you're creating a startup like this is that it should be scalable, so you can turn it from 2. And this is, by the way, how I came up with this idea. Our last startup, which was more of a traditional SaaS business, software as a service business, it went from 2 to 100 salespeople in 3 years. And I thought, naive, you know, that I would get 50 times as much sales during that time. And guess what? That didn't happen. And I figured that if we have a demystify box for sales, that could happen. I'm just going to show you the slide here again. Any other questions? What was your question, Henrik?
Actually, it's related to that. So is your plan, I mean, you already had 3 SaaS startups and you sold them. Are you planning also to grow this and then sell it? Or
no. The plan is to just, you know, make every single one of those demystify boxes in every category and rule the world.
Okay. And one more question. Since we are in the university, did you work with any university to produce all the AI that is behind this?
Well, we have a really active collaboration with a lot of the universities here in Barcelona and then some other ones outside. So we have all the time new people coming in, recent graduates and interns and stuff like that are coming in and working. So at any given time, we have 2, 3, 4 interns in our data science team that are coming from the universities. And then also in our other business units, we have marketing, we have, you know, G&A, product management and so forth. So we have a really amazing team there. This is talking about we realized value, potential value. When you can show generation of value in your product, it makes a big, big difference if you're selling to businesses, right? And this is obviously a business-to-business product. Anything else?
Thank you. Any other question?
As you said, like you are saving data goes in there, and then results comes out. So I'm just wondering, is it as different customers will have different needs, so you have one database for every customer, or you have a combined database for all of them? If it's a combined one, how it gonna work?
That's a great question, and again, a topic in its own right. We have created what's called a multi-tenant system. So for those of you guys that have software engineering backgrounds, that's how all SaaS applications are built today, right? You share the code base and you share the database and you segment up for each customer a separate thing. What Cien has done that is even one step further is to create a multi-tenant ML engine. So we have come up with ways to run our machine learning engines in parallel. That's why we're doing, hundreds of millions of predictions every single day. And we're segmenting out those. And then we have what we call the local and the global models. The local models are the ones that are unique to your company because each company behaves in a different way, right? So we cannot just assume that a single algorithm will answer every single one of those. So that's why the retraining of their data comes in. And then you have some problems that are more general and where you can use a global model that answers it for all customers the same way, right? Did that answer your question?
Okay, we've run out of time, so thank you very much, Rob.
Okay, thank you.
Please.
It's great having you.